Hi guys, welcome to my channel. Imagine you are an analyst with 1000 financial assets. You want to identify groups of assets that behave similarly, but there's a problem. You don't know whether there should be 3 groups, 5 groups, or 20 groups. With K means you had to make that decisions upfront. But what if you want an algorithm that shows you the entire structure of the data, from the small individual groups all the way up to the one large group? That's where hierarchical clustering becomes extremely useful. Instead of asking, how many clusters should I create? Hierarchical clustering asks, how are the observations related to one another at different levels of similarity? And the best way to see that structure is through a powerful visual tool called dendrogram. Once you understand the dendrogram, hierarchical clustering becomes much easier. So let's start with the core idea. Hierarchical clustering is an unsupervised learning technique that builds a hierarchy of clusters. And here's the important difference from K-means. K-means require us to specify the number of clusters K before the algorithm starts. Hierarchical clustering doesn't require a predetermined number of final clusters. Instead, it creates a sequence of clustering solutions. At one extreme, every observation is our cluster. At the other extreme, every observation belongs to one yen cluster. Between those two extremes, we get different level of grouping. This creates a hierarchies, and that's why it's called hierarchical clustering. There are two major approaches: agglomerate clustering and device clustering. The easiest way to remember the difference is agglomerate means bottom up and devices mean top down. Agglomerates start with many small clusters and gradually combine them. Devices start with one large cluster and gradually split it apart. So they are essentially moving in opposite directions. Let's start with the more common approach. Agglomerates, hierarchical clustering. Think of the word agglomerate as meaning together, thing together. We begin at the bottom. Every observation is treated as its own individual cluster. Suppose we have 5 observations. We naturally have 5 observations, 5 clusters. Nothing's have been compiled yet. Now the algorithm asks which 2 clusters are closest to each other. The algorithm calculates distance or similarity between the observations, then it identifies the 2 closest clusters. Those 2 clusters are merged. For example, perhaps observation A and observation B are the most similar. They become one cluster. Now we have 4 clusters instead of 5, and the process continues. The algorithm now looks at the remaining cluster. Again, it finds the 2 closest. It merges them, then it searches again and merges again. This process continues until eventually every observation belongs to one single cluster. So the entire process looks like this. Start with many individual clusters, gradually combine the closest cluster, continue merging, eventually arrive at one large cluster. That's agglomerate hierarchical clustering. Now let's research the process. This is device hierarchical clustering. Instead of starting with individual observations, we start with one yen cluster containing every observation. Then the algorithm divides that cluster into smaller groups. It continues splitting and splitting again until eventually every observation is our cluster. So remember, agglomerate bottom up start with individual and merge. Device top down start with everything and split. That's one more the important distinctions. So now we get to the more important visual tool in hierarchical clustering, a dendrogram. A dendrogram is essentially a tree-like diagram showing the hierarchical relationship between observation and cluster. The horizontal axis shows the observation of cluster. The vertical axis represent distance measures, and this vertical dimension is extremely important. The higher 2 clusters are joined on the dendrogram. The greater the distance between them, the lower they are joined, the closer or more similar they are. So the dendrogram lets us see the entire clustering process visually. Here's the key in the rule. Shorter turning distance mean greater similarity. Longer turning distance mean less similarity. It made two observations that are joined very low on the dendrogram. That means they are relatively close. They are highly similar according to the distance measure being used. Now it made two clusters that don't merge until very high on the dendrogram. That means they relatively far apart. They are less similar. So when you're reading a dendrogram, always pay attention to the high at which cluster merge. Here's another major advantage. We don't necessarily have to decide the final number of clusters before running hierarchical clustering. Instead, we can examine dendrogram and decide whether to cut the tree. For example, it may withdraw a horizontal line across dendrogram. If the line intersects three branches, we have three clusters. Move the line higher, we might have get two clusters. Move it lower, we might get like five clusters. So the dendrogram gives the analyst flexibility. The algorithm produces the hierarchy first, then analyst can choose the level of clustering that make the most economic or statistical sense. Thanks for